Kinetic theory of gases, question number 11. Figure shows a cylindrical tube with adiabatic walls and fitted with a diathermic separator. The separator can slide in the tube by an external mechanism. An ideal gas is injected in the two sides at equal pressures and equal temperatures. The separator remains in equilibrium at the middle. It is now slid to the position where it divides the tube in the ratio 1:3. Find the ratio of the pressures in the two parts of the vessel. In this question, there is an cylindrical tube with adiabatic walls and which contains one diathermic separator which can slide in the tube from left to right and right to left. Now we are injecting the ideal gas from both the sides with equal pressure and equal temperature. Due to this diathermic separator which must be remains at the middle. So that's why in this case what are the constants are there means here ideal gas with pressure and temperature is constant. Now afterwards what happens here? Adjusting the diathermic separator. This diathermic separator can slide by external mechanism. So that's why this diathermic separator can adjust the tube in the ratio 1:3. But here what is that? 1:1. So in this particular case the pressure and temperature which remains constant. So according to the gas equation, PV is equal to nRT. So in this case, number of moles constant and temperature are constant and R is also constant, universal gas constant. But in this case, what happens here? Here 1:3, the tube is divided. So that's why what is the volume present here? That is V by 4. And here what is that? 3V by 4. The volume is only divided. Why? Because pressure and temperature remains constant. So here in this case what happens? PV is equal to nRT. But in this case remember, whenever the number of moles constant, universal gas constant, temperature is also constant. But which one is changing here? By changing the volume, pressure only changes. So that's why what happens here? P1 V1 is equal to nRT. So here P1 V1 means what is that here? V divided by 4 is equal to nRT. This is the equation number 1. Now P2 V2 is equal to nRT. So here P2 times V2 means what is that here? 3V by 4 is equal to nRT. Now I want to find the ratio between pressures in this tube. That is P1 V1 divided by P2 V2 is equal to nRT divided by nRT. So both gets cancelled. P1 V1 is equal to P2 V2. So that means P1 divided by P2 is equal to V2 divided by V1. Now here P1 divided by P2. So from these two equations, V2 is how much here? 3V by 4 divided by V by 4. V by 4 cancel. P1 is to P2 is equal to 3:1. This is the solution for question number 11.